In section 5.1, we're going to be looking at solving linear systems of equations with technology. Specifically in part A, we're looking at graphs and tables to solve systems. A system of equations is a set of two or more linear equations. Well, a system, by the way, can be of any type. We're going to be specifically looking at linear equations for this section, looking at two linear equations, but we'll see some linear and nonlinear later on. Okay, and a solution to that system is going to be any point that satisfies all of the equations in the system. So it makes the equations all true. So we're going to look at a couple in table form and then in graph form down below. So first we have two equations, and we're going to fill in the table for each equation. So we have a list of x values, we're going to fill in their y values. Alright, so negative 2. Negative 2 times 2 is negative 4, minus 1 is negative 5. Positive 2 times negative 1 is negative 2, minus 1 is negative 3. 0 is negative 1. 2 times 1 is 1, minus 1 is 0. And 4 minus 1 is 3. Alright, we're just going to do the same thing with the next one, fill in all these x values, and then get the y's. So negative 2 makes that 2 plus 5 is 7. That's going to be 6. It's going to be 5. It's going to be 4. And 3. What we're looking for here is an ordered pair that satisfies both equations. So the ordered pairs are like negative 2, 5 and negative 2, 7, so they don't match. What we're looking at specifically, since they have the same x's, is for them to share the same y's. And so we see that happening down here because the two y values are the same with the same x value. So the point that these two equations have in common is the ordered pair 2, 3. So the ordered pair is 2, 3. That is the solution to this system. Does it have any other solutions? Graph to find out. So we're going to graph each of these equations and take a look at this graphically. Okay, so if I graph the first equation, it was at negative 1 for a y-intercept, slope of 2. So I can graph the first equation quickly here. And the second equation was y-intercept of 5 and then a slope of negative 1. So the second equation is going to graph real quickly here. Now I see the solution as the intersection of those two lines. So that point right there is the point 2, 3, and that is the solution to the system. Will they have any more? Well, because they're lines, they're going to continue on in the direction they're going without ever turning around. So they're never going to cross again. So a pair of linear equations can only have one intersection point, one unique intersection point if they're going to cross. There are a couple other cases that we'll look at on the next page. But it couldn't have just two, for example, intersections. Alright, so some of the cases that it might have. Alright. The first case is the independent case. Independent / intersecting. Technically, we could use the word independent in the second case as well. So we really want to use intersecting here. I'll highlight that. It's the intersecting case. And if it's intersecting, there is going to be exactly one solution. And this might look like what we saw on the previous page, just a set of intersecting lines where you have a singular solution. Okay. Now there are two other possibilities. One of them is if your two lines were parallel. If you have two lines that are parallel, there are going to be no solutions because your two lines will never cross. You think of the third case? Okay, we have the intersecting case where your two lines intersect in one place. We have the parallel case where they don't intersect at all. And our final case is the identity case. The identity case is where both lines are the same line. So when they're both graphed, we only see one. So those intersect at every single point because they're right on top of each other. So the solution set is going to be every point on the line. The number of solutions is all points. First of all, there are infinitely many solutions. But what is the solution? It would be all points on the line. Often you would write, if you knew the equation, you would write all points on the line and then give the y equals form of the equation. So, example, all points on, let's just say that this equation is y equals x plus 1. Looks like about a slope of 1 and an intercept of 1 if we just assume that my scale is like that. So that would be one example of a solution if you had an identity system.